Let's graph 6 basic functions. The first one we're going to graph is the constant function f of x equals 2. The graph of that, remember f of x can be written as y equals 2. And if you're not sure if that's a horizontal or vertical line, make a t-chart, and since y is 2 everywhere, there's a 2, 2, 2, and that means x can be anything. And if you graph these 3 points, you'll see it's horizontal. So 1, 2 is that point, 2, 2, and 3, 2. So the graph of f of x equals 2 is a horizontal line. Now the domain and range. The domain is how far left and right the graph goes. And so in this case it goes from negative infinity to infinity. And the range is how far up and down the graph goes. So in this case, we see that the graph doesn't go up and down very far at all, it just stays right at 2. So instead of an interval, I write it as a single point, which is called a singleton. So that's the range. Now, let's move this back up and graph a linear function. So f of x is equal to, let's just do 2x plus 1. And that's a nice linear graph that looks like this. Now remember, this is y equals, let's see if I can, okay, let's see if we can do that again. So here we're going to do y equals mx plus b, where b is the y-intercept. So we'll go up 1 and put a dot. And 2 over 1 is the slope. So slope is rise 2, run 1. So that's from this point right here. So rising 2, run 1, and put our second dot. Rise 2, run 1. And we can connect that. No, not perfect, but it's okay. Okay, now let's do the domain and range. So how far left and right, that's how many of the x values show up on this graph. So this arrow right here and then that arrow up there shows that the graph goes all the way to the left and all the way to the right. So these are the x values, and that's the domain. Then how far up and down does the graph go? Well, we can see, let's move that over, that the graph goes all the way up and all the way down. So up here because the arrow goes up, and then down there because the arrow goes down. Those are the x values that this graph takes on. Excuse me, the y values. So negative infinity is all the way down, positive infinity is all the way up. Now, we'll do a quadratic function next. So let's do it as f of x. So we'll write f of x, since we're dealing with functions, is equal to, now in this one, let's just do the basic quadratic x squared plus 1. So what we have is, this x squared tells you it's the shape of a parabola. And if we make a t-chart just to guess where some of the points would be, plug in 0, you get out 1. That's the point right here. Plug in 1, you'd get out 2. Negative 1 would also give you 2. So what we see is this is a parabola that's been shifted up 1. So when we do the domain and range, remember domain is the x values. How far left and right does it go? So picture the graph. How far left and right does it go? It goes all the way left and all the way right. So it's negative infinity to positive infinity. Now, how far does it go up and down? Well, what we see is the graph has a lower bound right here of positive 1, and then it goes up to infinity. So we'll write the range as bracket 1 comma infinity, because it goes from 1 up to infinity. Now we still need to do, sorry about that, a little jumpy. What do we need to do? A square root and an absolute value. So let's do the square root function next. F of x is equal to the square root of x. Now, the graph of this is going to be limited. We can't put in negative values because we don't want to take a square root of a negative. So the smallest value we can put in right there is 0. Square root of 0 is 0. And then I can plug in 1. And then I'm going to jump up to 4 because that's the next perfect square. So 0, 0 is right here. 1, 1 is right here. And then 2, 3, 4. Let's say 4, 2 is right there. So this shape is kind of like that. It is a half of a parabola tilted on its side. So the x values are the domain, and the lower bound on that is 0. See that the graph doesn't go any further left than this. So 0 is my lower bound on the domain, and then I shoot off this direction towards infinity. Oops, let's change it to a pencil. So 0 to infinity. And then my range is how far up and down my graph goes. And again, what we see is this graph has a lower bound right here of 0 on the y-axis. So all these values up here are okay, but the graph stops. It doesn't go any further down than this. So this is a lower bound of 0 on the y's, upper bound of infinity. Now just to remind you, I'm going to tell you this is the x values that show up on the graph, and these are the y values that show up on the graph. So we still need to do a square root function. Square root function, f of x is equal to, no, we did the square root. We didn't do an absolute value. The square root of, absolute value of x. So if we look at a t-chart, just give us some idea of some of the points. If you plug in 0, the absolute value was 0. Plug in 1, the absolute value was 1. And then if we plug in negative numbers, they also come out positive. And that's enough to be able to get the general idea of the shape. There's 0, 0. There's 1, 1. 2, 2 would be there. Negative 1, 1. Negative 2, 2. So it's similar to a parabola, except it's pointy. This graph has no curve right here. It's just a V shape. So again, we ask ourselves how far left and how far right it goes. So the domain, this graph goes all the way to the left because of this, and all the way to the right because of that arrow. So we see a negative infinity, comma infinity. And then the range, those are the y values. So again, your eyes are sort of drawn to the fact that it has a lower bound when you look up and down. So it goes from here up. The lower bound then will be included because there's the point 0, 0's on the graph. So 0 to infinity. And that's 5 functions, and we'll do the piecewise function in a separate video.